Alright, so today we're going to be talking about average rate of change, which is basically just when you take the rate of change just between 2 points of a function or of a curve. Average rate of change, the model for finding it, can be modeled as f of b minus f of a all over b minus a. Now this is basically how you've learned it in the past as change in y over change in x or rise over run. And just a visual example of what I mean by average rate of change would be the difference, or the rate of change between A and B on the curve at the bottom of the screen. Alright, so now I'm going to do a visual example of how to find the average rate of change. So we're just going to say that we are given the function right here with the 2 points 0, 0, and 2, 4 as marked. And so basically when we find the average rate of change, we're going to be finding the slope of the line drawn in orange. This is called a secant line because it hits the curve at 2 points. So the average rate of change would just be equivalent to the slope. So the way we find it is using our model of f of b minus f of a all over b minus a. We would take f of 2 minus f of 0 all over 2 minus 0, which would also give you 4 minus 0 over 2, which all just reduces down to 2. So that's the average rate of change from x equals 0 to x equals 2. Alright, so for a second visual example of how to find average rate of change, we're given the second curve, and we're given the points 1, 1 and 6, 3. And we're just going, when we find the average rate of change, we're going to find, let me redraw that. We're going to be finding the slope of the orange line, which is just the average rate of change among the curve from 1, 1 to 6, 3. And so the way we solve for that, again, we just use our model, f of b minus f of a all over b minus a. So we take f of 6 minus f of 1, we divide that all by 6 minus 1, which that'll give you 3 minus 1 all over 5. And that all reduces to 2/5. That's the average rate of change from x equals 1 to x equals 6, otherwise known as the slope of the secant line to the curve at 1, 1 and 6, 3. Alright, so now we're going to look at how to find the average rate of change mathematically. So for this example, we were given the function f of x equals x squared minus 2x minus 1. And we want to find the average rate of change from x equals negative 3 to x equals 2. So this one's just like the graph, except you have to do a little bit more math, but we're still following the basic model. So to set that up, how we would solve this, we take f of 2 minus f of negative 3 all over 2 minus negative 3, just like our model at the top. So then when we start to fill in the points, we see that we have negative 1 minus 14 all over 5, and that all reduces to negative 3. So negative 3 would be the average rate of change from x equals negative 3 to x equals 2. Negative 3 is the slope of the secant line that would connect the 2 points on the curve. Alright, so continuing on with solving for average rate of change mathematically, we're given the function f of x equals x cubed minus 1, and we want to find the average rate of change from x equals negative 2 to x equals 0. So again, we just follow the model and keep going from there. So we're going to take f of 0 minus f of negative 2 all over 0 minus negative 2. So when we start to fill things in there, we've got negative 1 minus negative 9 all over 2. And when we reduce all of that, it comes to 4, meaning that 4 is the average rate of change from x equals negative 2 to x equals 0. 4 is also the slope of the secant line to that curve. So that's how you find average rate of change graphically and mathematically. And just remembering that finding the average rate of change is f of b minus f of a all over b minus a. And that's where b is greater than a, and the b and a represent the x values. So as long as you can remember that f of b minus f of a over b minus a is the same thing that you've learned all along as change in y over change in x, or rise over run. But this one specifically means average rate of change, which is also the slope of the secant line to the curve.